Welcome back. Now I am going to discuss about a very simple application of Coulombs law that you all know that in case of an uniformly charged spherical cell, you have several types of proof regarding this, that at any point the electric field intensity at any point in case of an uniformly charged spherical cell, it will be zero. The same thing can be proved by applying the Gauss's theorem also, or by Coulombs law also. Today I am focusing on how to prove it by using Coulombs law. This is a uniformly charged spherical cell. Okay. Now charge is uniformly distributed here. Let the surface charge density over this spherical cell, it is sigma. Uniformly charged distribution means you all know that at any point, if I consider unit area, the charge contained by the unit area considered at any point of this spherical cell should be a constant. Okay. Now, this is a point P, an arbitrary point P. Let the radius of the cell is A. This is an arbitrary point P. You all note that it is an arbitrary point. I have not taken this point at the center. It may be located at anywhere. Markers. Sorry. Now I am drawing two cones, taking P, this point P, as the apex of two cones. One is this, another is this. Okay. Obviously, you all note that the base area subtended by this cone, let it is ds1, and the base area of this side, let it is ds2. Now, both the cones have subtended the same solid angle at the location of the point P. Both the cones have subtended the same solid angle at the location of the point P. And you all know what is solid angle? Normal area divided by distance square. Okay. Now, let the solid angle subtended by this ds1 or this ds2 at point P, let it is represented by d omega. Okay. Let the solid angle subtended by ds1 or ds2 at point P, it is d omega. Now, you join, let this distance, let it is r1, and this distance it is r2. It is the center of the spherical cell. Now, let us join these points. Now, this is a radius, this is also another radius, these two sides are same. So, if this angle is theta, then this angle will be also theta. Okay. So, I can write d omega as ds1 cos theta by r1 square. It is normal area by distance square, or the same thing, it is also, that is ds2 cos theta by r2 square. That means we have ds1 cos theta by r1 square equal to cos theta by r2 square. That is ds1 by r1 square equal to ds2 by r2 square. Okay. Now, the charge contained by this element ds1, it is sigma into ds1, because charge in unit area, it is sigma. So, this charge contained here, it is sigma into ds1. Similarly, charge contained by the area element ds2, it is sigma into ds2. Now, what is the electric field intensity at point P due to sigma ds1 and sigma ds2 amount of charges? You all know, I am again repeating that in order to calculate the electric field intensity at a point, I have to place an hypothetical unit positive charge at that point, and the force experienced by the unit positive charge placed at that point, it will be the electric field intensity at that point. Now, these charges are positive, so the electric field intensity at P due to sigma ds1 will be directed in this direction, because there will be a force of repulsion. Similarly, electric field intensity due to sigma ds2 at point P will be along this direction, being also of the repulsive type. So, the electric field intensity at point P due to ds1 and ds2 can be written as 1 by 4 pi epsilon naught sigma ds1 by r1 square. It is due to ds1, and E2, that is at the point electric field intensity at the point P due to ds2, it is sigma ds2 okay. Now what is the, now these two electric field intensities are oppositely directed. So what is the net electric field intensity at point P? So the net electric field intensity at point P, it will be E-net, that is E1 difference E2, 1 by 4 pi epsilon naught sigma ds1 by r1 square difference sigma ds2 by r2 square. Why I have taken the difference sign? Because I don't know which one is greater. If it is greater, then it will be this minus this. If this electric field intensity is greater, then it will be that minus that. Okay. So it is difference. Now, from our previous result, from the concept of solid angle subtended by ds1 and ds2 at point P, I have ds1 by r1 square equal to ds2 by r2 square. So it is identically 0. Because it is a difference. Same two quantities when taken in the difference, it is a 0. It is 0. So at any point inside the uniformly charged spherical cell, electric field intensity is 0. That can be proved by Coulombs law. It is very easy, one line proof by using the Gauss's theorem. But if you are asked that prove the theorem, fundamental theorem, prove the fundamental result using Coulombs theorem, you have to proceed in this way. Okay? Okay. Up to now, I am coming back with another topic.